Okay, lists and loops. We're on slide 8 here, and we're going to use a loop to access each item of a list and, work with each item individually. So here we have the best method to access those list items laid out for you. List of colleges equals, and then we have a list of 4 colleges. This is an intentional duplicate because that becomes important when we think about how are we going to access the list. Are those list items unique, or might they have some duplicates? So the method that I'm showing you here will work no matter if you have duplicates or not. So it is going to be the most reliable for you. What we do is we try to figure out how many times should this for loop run. And the way we do that is here is the list name, and we figure out what's the length of that list. So in our case, that's 1, 2, 3, 4. Lin, list of colleges, would translate into 4. And then we run the range function against that. So it's range 4 is what it is. So no matter if I add items to my list, this will still work because I'm on the fly. I'm taking the length of the list and running range against it before I start this loop. And so the loop would be reset if I came back and changed my list members. And so that's pretty great because this would basically translate into for index in range 4 in this case. Okay, so within then we are printing college and the hashtag and then the index of that first one plus 1. So the first one that we would come up to at index 0 would be MCTC. And we do the plus 1, so it's college number 1 when we run it, rather than being college 0. And then basically that would be accessing the index of the list item, which is important. And then here, when we want to access the name of that list item, I will, once again, I'll have my list name, and what comes in the square brackets would be index, which is that variable right there. So this index, the first time through the loop, is 0. Next time through the loop, that'll be 1. So that keeps updating when the loop runs. So therefore, first time through I'm going to get this name, second time through that name, and so forth. So let's see how this works. You guys should definitely copy that one. I've already done that, so I could run that over here. Best method. By the way, I want to credit Marty for, really getting that through my thick skull, why it's the best. So shout out to Marty. Alright, it prints this nice printout that, in a way, what I'm revealing here is the index as well as the name of the list item. Now, this part at the bottom, this is listed for the curious. So if you're happy with this block here, you don't even need to worry about this. But I do want to point it out because in your travels, you may find this same type of operation being done for college in list of colleges. Sounds really nice and simple, doesn't it? The problem comes up is when you have the duplicate list items. So I'll actually go ahead and run that just so you can see what happens. It's a little bit different setup. If I run it, it does run quite nicely. The syntax is a little bit different up here. But look what happens. College 1, name MCTC. 2, Metro. 3, Single College. And then look, it's like it knows that this is a duplicate. It says, hey, that's College 1. It's not College 4. Alright? So most of the time, we want to operate on each list item individually, even if they appear to be a duplicate. Okay? Think back to my list of students. Usually I have 2 students with the same name. Well, I want to treat them separately because they're 2 different people. So that's where the preferred method would be the one at the top of that slide. Okay, so these two methods are both going to be out there though, and this one, it can be used if you're absolutely certain that there won't be any duplicates. Like if you have a list of emails, they're not going to be duplicated, so that would work out just fine. All right, let's go ahead and number 9 here, slide 9. This one will be important for the lab and the homework because here we're dealing with numbers. And as you know, when we're dealing with our counting game and our quiz averages, we're dealing with numbers. So here we have an example where the rainfall amounts, list of floats, we've got a total. And then we're going to use the loop, just like we did on the previous slide. And inside the loop, we're going to accumulate that total rainfall by pulling out the list, rainfall amounts, and the index reference. So first time through the loop, it's index 0, and it will, pull out that 0.8. Second time through, it'll pull out 1.1 at index 1, and total that into our grand total, and so on and so forth. So this is a way of adding list items when they are numbers. We pop outside of the loop once those all run through in order to figure average like we did before. And so total rain now that we have calculated will be divided by, this time it's len, and that's the list name, the length of the rainfall amounts. So the printing should be familiar to you, and this is not too complicated, but you might look at it and say, there must be an easier way to total list items. And indeed there is. So here's a shortcut. If you don't need any detail about the individual list items and you only need the sum, then you would be able to use these shortcuts. Okay, total rain 2 equals sum of rainfall amounts. That's awesome. So great shortcut. That right there would take the place of this whole piece. Awesome. And then average rain, you would just do sum rainfall amounts divided by len rainfall amounts, which would be a nice way to do it. So if I run these two, they turn out to be exactly the same. It's just that this is a much shorter way of doing it. So why would we even care about this method? All right. We care about it because oftentimes we need to retain the detail about each item. Many times we won't just be accumulating a total here. We'll be doing other things like printing it, doing a mathematical operation on each and every list item, something like that. Then you need the long form. All right, so let's take a look at the next slide. We could run this just so you can see rainfall amounts, especially since this slide is referenced in the homework as a key. And you find that longhand and shorthand, they come out the same. So if all you need is something like a total and average, by all means use the short way. But do study the long way, and then we'll see here on slide 10 how that comes into play. So here we've got, very similar to the top half of the previous slide, but we want to show something going on with each list item. We're going to take each list item, we're going to square it. So we have a list of numbers, same setup here, and we're accessing each number in the list by its index. But then we're squaring that number. And beyond that, we are printing in a nicely formatted fashion. So that's where you can't do that with a summary or a shortcut. You need to be using the loop for that. Okay, so let's see how that works out. That's this one. And sometimes the toughest thing about our problems is the way you're asked to print. and that is going to be the case this week too. So here's a beautiful table, and it's telling us each list item squared is 1. 2 squared is 4. So it's printing each list item, but it's also printing the result of that mathematical operation. It's also formatting. You see how these are right aligned, and these are right aligned. So, you can be very fussy inside the loop with each and every list item. All right. As we move forward, we need to take a breath and say, a list is a data structure. The reason we're able to do these awesome things with it is because it is its own data type, has its own methods, has its own properties. We are kind of passing over the whole topic of tuples. That is in our book, Chapter 4, but we don't talk about it much in the assignments. I try to make up for it by pointing out tuples whenever, I notice in class, and I want to make sure you see they are everywhere. They're used everywhere. After the midterm, we deal with another type, dictionaries. So, we can't cover everything in the beginning class, but lists and dictionaries kind of rose to the top along with ints, floats, booleans, and strings, of course. All right? So next we're going to find out what do you do if you don't have a list and you need one. You need to construct it. Up to this point, all the problems we're dealing with the situation where a list exists and you are just working with it. Now we got to build one from nothing. All right.